Welcome back. We are on page 18. We are more than halfway done and there's no turning back. Okay, number 86, part 1. Both of these parts, part 1 and 2, have to do with the sine and cosine of complementary angles. Now, I just want to go over that before we get started. So, sine and cosine of complementary angles, if I draw a triangle here, only works with right triangles. So if I have a right triangle, like I have pictured, the two angles, we'll call them angle A at the top and angle B, are complementary, meaning they're going to add up to 90. Now, because of the way the trig functions are set up, there's a funny little rule that we refer to as the sine and cosine of complementary angles, and the rule is this. The sine, let me fix that. The sine of angle A, for example, will equal the cosine of angle B. So you'll notice that in this rule, you're going to have opposite functions, sine and cosine, and your angle A and your angle B are going to be complementary. This could also work in reverse. So I could say that the cosine of angle A will equal the sine of angle B. Now, using those two rules, we have a couple of different examples, and it extends the examples a little bit further. Now, in these examples, we're looking at triangles that are overlapping. Now, you'll notice in this diagram here, the two triangles are overlapping, and you'll notice that it shows you that line segment AB is parallel to line segment CD. Keeping that in mind, there's a couple of things that you should note. The two triangles, which is the baby triangle, CDE, and then the big triangle, ABE, are going to be similar. The reason they're similar is because we have angle B and angle D as congruent angles, so that gives us one of the angles in order to prove triangles similar. And then also, since angle A and angle C are corresponding, given those parallel lines, that gives us our second pair of angles that are congruent, meaning because of AA similarity postulate, we can show that these two triangles that are overlapping are similar. Now, how does sine and cosine of complementary angles play in with similar triangles? Let's talk about that before we go ahead and do our problem. So I'm going to give myself a little bit of room to work. And here we go. If I have angle, or rather triangle, ABE, which is that big triangle, and then I have that smaller triangle, CDE, which is similar, that means all of the angles that match up are going to be congruent, all of the corresponding angles. I'm going to go ahead and I'm going to label everything. So I'm going to call this A, B, E, and then it's similar to triangle C, D, E. Angle B is congruent to angle D because they're both right angles. Angle A, we said, is congruent to angle C because they're corresponding. And then angle E is an angle that they share. So they share that angle. So those two angles are going to be congruent as well because of the reflexive postulate. Or reflexive property of congruence is a better way to say it. Reflexive property of congruence. So one thing that I want you to note when we have two similar right triangles is if I said sine of A equals the cosine of E in this first example, because A and E are the ones that add up to 90. So if I say sine of A is equal to the cosine of E, then instead of writing sine of A, I could also have a congruent angle to angle A take the place of sine of A. So I know angle A and angle C are congruent. So instead of writing sine of A, I could have also written sine of C would equal cosine of E. So I just want you to keep that in mind, that because the two triangles are similar, we can have some of those angles be replaced with an angle that it's congruent to from the other triangle. Okay, so let's take a look at our particular question. Okay, I'm going to clear this off a little bit. Okay, so for this question, it says in part 1, sine of E is equal to blank. Okay, looking at our little triangle here, I'm going to zoom in, and I'm going to mark, they're talking about angle E. Now, angle E is complementary to two angles. It's complementary to angle C. It's also complementary to angle A, because angle C and angle A, we know, are congruent. So, when it says sine of E, naturally, I want to use my sine and cosine of complementary angles rule and start writing the word cosine. So sine of E is equal to cosine of blank. Cosine of the angle that's complementary to angle E. Well, like we said before, it could be either angle C or angle A. So let's look at our choices. The first one talks about the tangent. The tangent has nothing to do with our sine and cosine rule. The next one says cosine of A. I do like the fact that it says cosine, and we know that angle A is complementary to angle E. So I think it's going to be choice B, but let's go through. Choice C says sine of A. Well, it's not sine. It's always opposite functions there. Sine turns into cosine, cosine turns into sine. So you have to have opposite functions there that you're going to set equal. So I'm not going to use the sine. And lastly, they have tangent. That's not going to be it as either. So it's going to be choice B. Okay? Sine of E will equal the cosine of A. And remember, the reason for that is that the two angles, angle A and angle E, are complementary, meaning they add up to 90. So angle A and angle E. If, for example, angle A was 60 degrees, which I don't know if it is, then angle E would be 30. They would be complementary. Okay, let's go on to part 2 of this question. So for part 2, we have sine of A equals. Now, naturally, I'm thinking I'm going to write cosine here. But when I look at my choices, I notice, oh, they're not really asking me about the cosine of whatever the other complementary angle it is. They're specifically asking me what's the ratio, what's the sine of A. So I'm going to erase cosine. And now I'm going to think to myself, sine, well, I'm going to do so, ka, toa. And it's going to be the so, right, for sine. So means opposite over hypotenuse. So I want the opposite over the hypotenuse. Now, here's my issue. Looking at my diagram, it's going to clean it up a little bit. Looking at my diagram for angle A, I know that I'm not going to have enough information for the opposite side and the hypotenuse. Opposite to angle A would be the entire side length, BE. And I don't have that side length. And then the hypotenuse would be all of AE. And I don't have all of AE. So I'm not going to be able to talk about angle A. But what I can talk about is the angle that it's congruent to. So I know that angle A is congruent to angle C. So if I talk about angle C and figure out the sine of angle C, then I can go ahead and come up with my fraction. So I'm not going to talk about sine of A anymore. Let me talk about sine of angle C. Okay, so with angle C, opposite to angle C is the 4. So I'm going to start putting 4 over the hypotenuse. Now my hypotenuse right now is missing. I'll call it x. But since it's a right triangle, I can always solve for the hypotenuse. Now you should note that this is a very special triangle. It's 3, 4, and the last side is going to be 5. It's a special right triangle. It's a Pythagorean triple. It's a 3, 4, and the last side length x will always be 5 if we're looking for that hypotenuse. So I don't even need to use my Pythagorean theorem. I know that this last side length, the hypotenuse, is going to be 5. So filling in my O over H, opposite over hypotenuse fraction, I'm going to put in 5 for the hypotenuse. So it's 4 over 5, which gives me the sine of C. And whatever I get as a sine of C, well, it's going to be the same thing as sine of A because the two angles are congruent. So my answer is going to be 4 over 5, which is choice D. Okay, there's one more question that has to do with this sine and cosine of complementary angles. Let's take a look at it. Okay, number 87. Sine of M equals blank. Now, 87 is a completely separate question. There's not even a diagram here. Now, what I want you to think about is they're still going to be talking about the sine and cosine of complementary angles. So if I have my right triangle and I'm going to label that my angle M is at the top, and I'm going to put my right angle symbol. So they're asking me, well, what's the sine of M going to be equal to? And using that rule of sine and cosine of complementary angles, I'm going to replace sine with cosine. And then instead of angle M, I need to figure out, well, what's the other angle going to be? They don't give me a measurement, but if I called angle M, let's say 20 degrees, then to get the other angle down here, I would subtract 90 minus 20 to see what's left over for that angle at the bottom. And that would leave me 70. Now think about what I did. I did whatever this angle was, subtracted from 90 to get the measure of the angle down here. Now, since I don't know the measure of angle M and I just made something up, I'm not going to use 20. I'm going to use M. So 90 minus M should give me the measure of the angle at the bottom. I don't know what M is, but if I do 90 minus the measure of angle M, that gives me this angle right here at the bottom. So I'm going to go with choice A because it says cosine instead of sine, and because it subtracts M from 90 to see what's left for the complementary angle. Okay, so the big takeaway from this is look for opposite functions here. Sine and then cosine. And then make sure that your two angles, M and whatever the measure is here, are going to add up to 90. You want them to be complementary. Okay, let's move on. Number 88. Find the value of x and y, round to the nearest hundredth if necessary. So that's 2 decimal places. Now looking at my diagram, I see it's a right triangle, so I'm thinking I'm either going to use Pythagorean Theorem or I'm going to use Trig. Now, since I don't have enough information for Pythagorean Theorem, I would need 2 side lengths to use a squared plus b squared equals c squared. I'm going to have to use Trig. Now, they gave me a reference angle of 30 degrees. That 30 degrees is my reference, so now I can assign opposite, adjacent, and hypotenuse. Opposite the 30 degrees is a side length of 10. The hypotenuse is always across from the right angle. So if this is my right angle, across or opposite from that right angle is the y. So this is my hypotenuse. And then the last side length is your adjacent side. It's next to the 30. And adjacent means next to. So now that I have O, A, and H labeled, I'm going to look one at a time and figure out what is X and then what is Y. You cannot find X and Y at the same time. It has to be one at a time. Okay, so let's start with X. So if I'm going to be solving for X, I want to completely ignore the other variable. So imagine this doesn't even exist. So we're left with opposite and adjacent, O and A, which means you're using TOA, tan. So we're going to set up our tan function. It's tan of the angle 30 equals your opposite, which is the 10, over your adjacent of X. Now there's a trick here. Whenever you see that the variable is on the bottom, and we see the X is on the bottom, we're going to have it switch with the trig function. So it's going to be X in place of the tan of 30 equals 10 divided by the tangent of 30. So in the calculator, I'm going to click 10 divided by, and make sure you do 30 before you hit tan. So I did the divided by. Now I'm going to do 30 tan, and it's going to tell me what the tangent of 30 is. It's like 0.5773. So I'm going to say yes, that's the tangent of 30. Use that as the denominator. Equals. So it's 17.32. So my answer for x is 17.32, and that's rounded to the nearest hundredth. It's out 2 decimal places. So 17.32. Now let's move on to y. So if I'm going to be solving for y, which is my hypotenuse, I'm going to completely ignore the x value. I know I've already found it, but it's rounded, so you don't want to use it. So completely ignore the fact that x exists. Look at what you're left with. You're left with 10 and y, which is your opposite and your hypotenuse. O and h means that you're using the SO function. So, ka, toa. So. So means sine. So we're going to do sine of 30 equals your opposite side, which is 10, over y. And again, notice that your variable is at the bottom. So you're going to switch it with the sine of 30. They're going to switch places. So you're going to have y equals 10 divided by sine of 30. So go to your calculator. You're going to do 10 divided by 30 sine. So 30 sine. It tells you that the sine of 30 is 1/2, which is 0.5. And then you say, yes, use that number. You hit equals. So y is actually a nice whole number. It's exactly 20 units. So we're going to put down 20 for the length of y. Now, some of you may have noticed that this is a special right triangle. This special right triangle is our 30, 60, 90. I'm going to erase what's here, and I'm going to remind you how would you work with this using the 30, 60, 90 triangle relationships. So 30, 60, 90, you start with the 30 degrees, opposite the 30. We call it x. And I know it says x at the bottom, but we refer to it as x, the smallest, the shortest side. Now, the side next to the 30, I'm going to ignore the fact that it says x here. The side next to the 30 is x, or your shortest side, times radical 3. And then your hypotenuse is always 2x. Okay? So again, ignore the fact that it says y. Now, since I was given x, I was told that x is a value of 10. Then I'm going to use that x value and plug it in wherever else it exists. So right here, it says x times radical 3. So that would be 10 times radical 3, or 10 radical 3. Notice if I put 10 radical 3 in the calculator, I'm probably going to get the 17.32. But let's check. So 10 times 3 square rooted, which is about 1.7, equals. Yep. Notice I get 17.32. And I didn't even need a calculator to know that it's 10 radical 3. Now, lastly, since I've now figured out the 10 radical 3, my hypotenuse is 2 times the length of x, or 2 times the shortest side. So 2 times 10 is 20, which is the same thing I got for y when I did the trig method. So just note that for your special right triangle, your 30, 60, 90, you could do it without having a calculator and get exact values. So just to recap, our 30, 60, 90 special right, I'm going to draw it for you. So let's say that's our triangle. I'm actually putting the measurements in some different places this time. So if this is my right angle, and this is the 30-degree angle, which is completely different than what our figure looked like, but we did notice the 30 degrees. Across from the 30 is called x. It's your shortest side. Now, next to the 30, the leg next to the 30 is the length of x times the square root of 3. And lastly, the hypotenuse is 2x. So as long as you know these relationships, you can find any of the missing side lengths using these relationships and plugging in for x if you're given x. Okay, let's move on. Number 89. Find the perimeter and area of the triangle shown to the nearest hundredth. So our final answer is going to be to the nearest hundredth. Every answer in between, though, you're going to want to go out at least 4 decimal places before you tell me the perimeter and the area. So let's start with perimeter. To find the perimeter, you're going to be adding all the side lengths together. Now, right now, we only have one side length. So we're going to have to solve for x and y before we can get the perimeter. Now, if I start setting up my perimeter problem here, I'm going to have 3 spaces because there's 3 side lengths. One of them is going to be the 26. Another one's going to be the x value, and the last one's going to be the y value. Now, looking at your right triangle, you're thinking either trig or Pythagorean theorem. Now, clearly, you should note that this is going to be trig. You do not have at least 2 side lengths, which makes you able to use a squared plus b squared equals c squared. So we're going to use trig. Remember what we do when we start using trig. You start with your reference angle, you label the opposite side, then label the hypotenuse, which is the 26, it's across from the right angle, and then your adjacent is the x. We're going to use one variable at a time. So let's start with x. If I'm solving for x, I want to ignore the other variable. So I'm going to pretend that this y value doesn't exist. So I have a and h, which is cosine. A and h, So I'm going to do cosine of 24 equals your adjacent x over 26. Now, your denominator is 26, and that's what you want to get rid of. So you're going to multiply both sides by 26 in the calculator. The right side will have the 26's cancel. So let's do it. 24 cosine. I like to do my trig function first if I can. So 24 cosine is about 0.9135. Multiply that by 26. And we're going to get 23.75, so on and so forth. I'm going to go out at least 4 decimal places because that's not my final answer. I still have 2 other side lengths I need to add to it in order to get to the perimeter. So I'm going to write down that x is equal to 23.752, and then I'll say 2. I'm rounding to the 4th decimal place. Now that I have that, I'm going to fill this in. So I'm going to have, this is not much room, so I'm going to put it up top. 23.752. All right, now I need to solve for y. So same process. If I'm solving for y, I want to imagine that the x doesn't exist. And now my y is my opposite. I have the hypotenuse, so I'm going to use so, because it uses O and H. So to get the y value, I'm going to use sine, so sine of 24 equals my opposite y over 26. Same as before, I want to get rid of the 26, so I'm going to multiply both sides by 26. So on the right it cancels. Ooh. And on the left, I'm going to multiply by 26 again. And I do that in the calculator. So 24 sine times 26 equals. So that's going to be my value of y right there. So I have y equals 10.5752. I went out 4 decimal places because it's not my final answer. So that's going to go right here for y. I am going to zoom in a little bit so I can write it down. So for y, it's 57. 10.57 152. There it is. Okay, so now that I have all three side lengths, I'm going to go ahead and add them together in order to get the perimeter. So in my calculator, 26 plus 23.7522 plus 10.5752 equals. Okay, so that's the answer for my perimeter. I need to round that answer to the nearest hundredth, because that is my final. So 60.33 would be my answer. 60.33 units. It could be feet, it could be inches. I don't know what it is, so I'm just going to write units. Let's move on to area. So for area of a triangle, you're going to be using area formula equals base times height divided by 2. It's also known as 1/2 times base times height, however you want to go by it. Now, when you have a right triangle, I'm just going to clean this up a little bit. When you have a right triangle, your two legs that make up the right angle are always going to be your base and your height. It doesn't matter which one you call the base and which one you call the height, but you always use the two legs because you want to make sure your base and your height are perpendicular. So never use the 26, the hypotenuse, when you are doing area of a right triangle. So what I'm going to do is I'm going to multiply together what I got for x and what I got for y, and then I'm going to divide by 2. So in the calculator, I'm going to grab the 23.7522 and the 10.5752 and multiply those together. So 23.7522 times 10.5752 equals, divide that by 2 because you want half of it, and you go to 125.59, so on and so forth. So rounded to the nearest hundredth out 2 decimal places, my final answer is going to be 125.59, and it's going to be units squared. It could be feet, it could be inches, whatever they gave me. They didn't give me anything, so I'm just going to say units squared. Okay, let's move on to the last question. Oh, 2 more questions on this page. 90. Find the value of x and m, round to the nearest whole number if necessary. Okay, so x is a side length, m is an angle. I'm going to start by solving for m. When I have a right triangle and I'm looking for an angle, you have to use trig, but you're going to use trig in reverse. It's known as inverse trig, and we did it much earlier in this packet. Now, if I'm looking for angle m, that's my reference angle. So I'm going to still label opposite, and the 17 is your hypotenuse. We don't have x, so I'm not even going to label the adjacent side. O and H means so, sine. So I would normally set this up and say sine of angle M equals opposite side, which is your 15, over the hypotenuse of 17. However, when you're looking for your angle, what you're going to do to get M is you're going to do sine to the -1, the inverse sine of the decimal that you get when you divide 15 by 17. So in the calculator, you want to get 15 divided by 17 first. 15 divided by 17. So it's 0.8823. So in other words, to get m, you're taking the inverse sine of 0.882, and I'll round the last one 4, and it'll continue going. And whatever you get when you take that decimal and you take the inverse sine is your angle. So to do the inverse sine in the calculator, you're going to have to hit the second button. For me, it's this upwards arrow. So second, then you see that sine to the -1 pop up. Click that, and it's going to pop up with your angle. So about 61.92. I want to round to the nearest whole number if necessary. So here, instead of writing 61.9, I'm going to say 62. So my final answer for m is that it's about 62 degrees. That's the measure of the angle. So I'm going to put that down as m. I didn't have to solve for m first. I just chose to solve for m. Now, if I wanted to solve for x, I'm going to go ahead and erase what I have here. If I want to solve for x, this is a great time to use Pythagorean Theorem. You have 2 side lengths out of 3 for your right triangle. That is a time when you want to use a squared plus b squared equals c squared to solve for whatever's missing. Now keep in mind, your c is always the hypotenuse. That's always your c. The other 2 legs, it doesn't matter which one you call a and which one you call b. I'll call the 15a and I'll call the missing side length b. So when we go ahead and plug this into a squared plus b squared equals c squared, I'm going to substitute a with 15 squared plus x squared equals 17 squared. 15 squared is 225 plus x squared equals 17 squared. Well, most of us probably don't know 17 squared. We don't use it that often, but it's 289. If we subtract 225 from both sides, we're going to be left with x squared equals minus 225. You left with 64. Now you don't want x squared, you just want x. You just want the length of the side, not the side squared. So to get rid of the square, you're going to square root both sides. So the square and the square root cancel. Now you're left with x equals, the square root of 64 is exactly 8. It's a perfect square. 8. So 8 is the last side length. Now what does that mean? The fact that all 3 side lengths are whole numbers. That means it's a Pythagorean triple. This is another Pythagorean triple. It's the 8, 15, 17 Pythagorean triple. One of our 4 famous Pythagorean triples. Okay, so I'm going to go ahead and write in my final answer for x is 8. Let's move on to the last question on this page. Number 91. Find the altitude of the kite in the sky to the nearest whole foot when the string of the kite is stretched 100 feet and the angle of elevation is 52 degrees. Okay, let me go back. Find the altitude. Altitude is another fancy word for height. They're asking you to find the height, which means this vertical distance here is x. That's your height. Then they're saying that they want the altitude to the nearest whole foot. So you're going to the nearest whole number when the string of the kite is stretched 100 feet. So the string of the kite. In this diagram, the string of the kite is the slanted hypotenuse right here. So they're saying when that string is stretched 100 feet. So I'm going to label in that this is 100 feet. And the angle of elevation is 52 degrees. So that's the other measurement that they give us. Angle of elevation is always along the ground, along with the horizontal line, and your hypotenuse. So if I zoom in on this, my 52 degrees is going to be right here. It's going up from your horizontal. Now this is a right triangle. We only have one side length. We're looking for another. And we have an angle. Perfect scenario for trig. So we're going to use trig. Now, I need to start by labeling opposite, adjacent, and hypotenuse. So if my 52 degrees is my reference angle, opposite is this x value. Your 100 feet is your hypotenuse. And your adjacent, well, that's that horizontal line. We don't have it. They don't need us to solve for it. So we're not even going to label in the a. O and H, opposite hypotenuse. You're looking at sine. So, O and H. So we're going to do sine of 52 equals the opposite, which is x, over 100. So it's always opposite over hypotenuse. Now, you want to get x, so we're going to get rid of the 100 by multiplying both sides by 100. So in the calculator, we're going to do 52 sine, which is approximately 0.788, times 100 equals. So it's going to be 78.8 equals x. They don't want the decimal. They want it rounded to the nearest whole foot. So to the nearest whole foot, you're looking at rounding the 8 up to 9 or keeping it at 8. When you look next door, the 8 says round up. So you have to round that 8 up. So we're going to do 79 feet. Okay, so that is your altitude. That's how high this kite is. We are done with page 18, so let's move on.